On behalf of nStudio, I'd like to welcome you into our living room. Sit back, relax, and watch the channels that we like to watch. And join us for a special presentation of NativeScript plugins, a deep dive from Developer Days 2017.
We got Android specifics, iOS specifics, and we've got a lot of content. So we're going to try to cover it. We're going to do it in a little different way that you probably have seen before. Theater style. And scene.
What is my purpose?
Pass the butter. Thank you.
Dad, I need a ride to work.
Maybe Rick can give you a ride. I'm helping Morty with science.
I'm busy.
Doing what?
Anything else?
What is my purpose?
You pass butter.
Oh my god.
Yeah, welcome to the club, pal.
I love that scene. It really shows that the robot had no capabilities. But you know, there is a guy I've heard, Sebastian Widlick, who's been able to program robots with NativeScript via Bluetooth. And I think I know just the channel that may touch on this.
Now take you apart, find out which screw is loose.
Apart, undone, dismantle, dissect, disassemble.
Alright.
No, that is the wrong
No, I'm pretty
channel.
sure that's it.
No, that is the wrong channel. Hang on one second. Okay, so actually we need to start with, what is a plugin before we can actually dive into how you would possibly control that robot. You would have to know how to create a plugin with NativeScript, and where else would you get started creating a plugin with NativeScript?
Where would we get started, right?
Well, there are many options, but the suggested option would probably be the official plugin seed. It comes with a very great scaffolding right out of the box, built-in unit testing, built-in support for CI, and also a great workflow.
Now, hang on, this workflow is something that I kind of in debate about. Sometimes I kind of like to tweak my plugins. I don't know if I want to see you doing all that.
The workflow is very critical. There's many ways you can develop a plugin. You could control everything yourself and move things around from node modules to the app. But with the official plugin seed, everything is handled for you with a few commands. In the source directory of your plugin, if you run npm run plugin tsc watch, it basically kicks off the TypeScript compiler in watch mode. So any changes that happen in the source directory are going to get transferred into the demo app.
Now, this is from the official plugin seed. This is on the NativeScript org.
This is, yes, this is the official seed. So it also comes with the demo app. So in the demo app, once you run npm run demo Android or iOS, it's going to add the platform, it's going to build out the application with the plugin. And since TSC Watch is running, any changes are just going to get transferred over.
So you mean the changes I make in my source plugin files are going to get transferred to the demo?
Yes, that is correct.
Okay, all right.
So basically live sync for your plugin. So with plugins, there's a lot you have to know about Android if you're going to create a plugin that's going to tie into some native Android, either the APIs using some SDK. You have to know several different things that are related to native Android. And the first, and one of the most critical, is the manifest for the Android platform.
What's the manifest?
Well, the manifest is basically, it describes the structure of your application. It also has the unique name of your application as it gets published. You specify the permissions. Also, you can specify the minimum Android API that you're going to target, as well as the target API for Android. You also can specify drawables, which are basically the app resources, if you're familiar with those in NativeScript.
The drawables, that's a Java thing?
Yes, more or less. It's specifically related to Java.
So this is Android manifest is strictly, this all comes from Java, Android. There's nothing really NativeScript specific about this file.
No. This is pure Android. There's nothing NativeScript so far, but you will definitely want to know how to harness the manifest for your plugin. So also activities, services, and intents are going to end up in the manifest. Again, because it describes the structure of anything that your Android app is going to access as it goes forward. First, I want to actually tell you guys about the manifest and how it relates to the plugin. So in the plugin, basically, in the source directory, you'll have a platforms folder, and this is where you'll target Android and iOS. Anything specific to the native library or SDK that you're going to use, this is where it would go.
So what are we looking at, Brad? I see a plugin folder and there's platforms.
Yes.
What is plugin?
Okay, so plugin, think of that as the source directory. If this was the official plugin seed, consider that the source of your plugin. So there is a subdirectory for the platforms, and then also Android and iOS beneath the platforms. And so the manifest goes inside of the Android folder, obviously since it's related to native Android applications. And right here you'll see I've outlined here a few permissions. As I mentioned previously, this is where permissions go for Android. Any type of permission that your app can use, if it needs access to location, camera, audio, you have to specify those permissions in the manifest so that Android gives you access to those APIs.
Now this internet permission and get accounts, are some of these default?
There are some default ones typically when you create an Android application. These I just grabbed from something I was working on the other day. So it's not anything specific. And then also, as I mentioned, the activities, back to what Nathanael was saying, if your app is going to harness any activity that might come from a third-party SDK, typically you're going to have to specify that your app uses that activity in the manifest.
So this, I see Facebook in there. This is an example of a Facebook authentication?
Yeah, well, more or less. It is the Facebook activity, which basically is the login activity from the Facebook SDK, again, for Android. So I've specified that here in this plugin, in the manifest. And so when this runs in the demo app for your plugin, it's going to, the CLI is going to create the plugin, and it's going to merge this manifest with the actual manifest in your application. Does that make sense?
It does. Now, the structure of this, you got uses permission at the top, you got activity at the bottom. Does the order matter?
It does not. You could sprinkle it around. There are some node level values as far as how you can specify this tree here, but for the most part, you could have moved permissions below the activity. If you
and the manifest has to be the root node.
Yes.
There's never any node that encompasses these other points.
That is correct. So an activity, the way Android and Google describe it, is a single focused thing that the user can do. So think of it as one screen in your application. So for example, the Facebook activity, it has one purpose. It is to authenticate against Facebook's SDK and return something to you as you're consuming that SDK. And with NativeScript, the app has one core activity in the Android. It's TNS NativeScript activity, I believe, something along those lines. There is a second one, which is for errors, but the main driver of your NativeScript app is one Android activity, and your views, so all of your pages in NativeScript, get kind of shoved into that one activity. And so to understand activities, you need to have a decent understanding that an activity in Android has life cycle hooks, basically. So everything from when it's started, when it's launched, when it's paused, stopped, and resumed. So those activities are very crucial when you're working with plugins, because there are some SDKs and third-party libraries that you need to set up event hooks or listeners when these activity lifecycle events occur.
So this is a lot of information right here. The Android activity, is it tied to the view in any specific way?
Not necessarily. No, your view gets put into the activity. Does that make sense to you?
That does.
Okay, so when you create your view in Android, it's added to the activity. I forget the method now, but there's a method on the activity where you put the view into that activity.
So would you say every single NativeScript app out of the box, you said, has the one Android activity?
Yes, well there's two, but there's one core activity.
Core activity. What do they call that?
The core activity?
Yeah.
It's
is there a name for it?
NativeScript application.
Yes.
And then error logger.
And the error activity is the activity whenever you crash your NativeScript app. If you've ever done the Android NativeScript, you see that screen pop up and it shows you the log cat.
Is that coming from NativeScript? Is that NativeScript helping us with the error?
Yes, because that activity is from the NativeScript application hooking into the log cat output, basically to show you the stack trace of.
So this main activity that NativeScript creates, I just want to get, this is something NativeScript gives us to help us build an Android app.
Yes.
And otherwise, if we were building an Android app by ourselves, we'd have to create this activity.
Yes.
By ourselves?
Yes, you start with an activity when you create an Android application. Typically, it's a blank activity, or you start with a template step. And there are lifecycle events that occur with every activity.
What's like that first one?
I believe that's the start. So it's created, and then it's started, and then also it's into the pursuing method. So if you, which I'll get into that, how that ties into plugins, again, because you're going to need to know those events occur and how you
I think these would be pretty important, right? This is queuing when the app starts, and then also queuing when the app goes into the background?
Yes, you can track the life cycle of the activity. In Android, rather than it being considered an application, each screen is typically an activity that you can launch independently. NativeScript does it a little bit differently in that we only have one activity and everything runs inside that activity. And so they expose some of that functionality to us at the JavaScript layer. But in a true Android application, native Java, each activity is like its own little separate world. And so that's basically the difference between the two.
Are there any limitations that you guys know of that being inside of this NativeScript world in that sense and how it is managing the lifecycle would invoke, or you still have full control?
You still have full control. The only limitation I can think of is you really can't run two NativeScript apps inside of itself. You can't like run the activity a second time from itself. I don't believe, but that's not something you'd want to do anyway.
If you were to create an Android app on your own, would that be something that's beneficial? To run two activities within itself?
And yeah, in a normal Android application, you do run multiple activities. An activity transfers control to another activity, which then transfers control to another activity. And so each screen typically has its own activity. Where NativeScript, we do each screen as a separate, piece of JavaScript code that you just load in and use navigate to in normal plain NativeScript. And
so like, I'm just going to give an example. If I was logging into Facebook or Google and it launches some off screen, that's a separate activity?
Correct.
Does it have to be a separate activity?
It typically is, because that's the way Android was written, is to each thing is a separate activity. And that's the reason why when you're integrating plugins into a NativeScript, you have to understand some of this activity stuff, because NativeScript does not do activities the same way. Everything runs in one activity. And so you have to sometimes say, oh, I want to call this activity so that it pops up their screen, and then that screen, when it's finished, it resumes your activity. And so you have that life cycle of when your screen finishes, when your screen restarts. And so you can continue your path of code.
Understanding that the activity has lifecycle is important for the plugins. And right here in this example I've got, consuming this SDK, or this Android library here, is calling this open activity method, which is basically calling the onStart activity for result method in Android. And the way this library is set up, the important thing to see here is this fourth argument is a number, and it is the request code that relates to that activity. And why that's important to know when you're consuming and tying into the activity results or the application that's in NativeScript is NativeScript has the activity result event, which you're going to tie into when you consume that third-party code. And one of the properties that gets returned here is you see the request code, and that number is always, or it should always match up, because that's how you know you're in the direct result event for that method.
Where does that number come from?
You can set it to whatever you like.
So when you open activity, you're just identifying that activity to call back with that request code.
Yes.
And this is typically seen in some type of third-party integration on Android.
Yes. If it opens up an activity, there's going to be a request code if it has a result that you are trying to get data back to, or from when it returns.
Now I see something here that's kind of interesting. App.Android. App is from NativeScript.
It's the application module.
Yes. And Android off of that is, what is that exactly?
It's a property that specifies the Android instance from the app.
The Android instance as in the instance of the app, so the global instance of the app?
I believe so, yes.
Yes, it is the global instance of the application and has access to certain global properties that you might need through your lifecycle of your NativeScript application.
Now the event that you're wired into, that's just a static, it's just a convenient access. That I assume is some type of string.
Yeah, there's a string value.
Correct.
Activity result, I believe.
Yes, there's activity result. There's about 10 of them that are built into NativeScript. And you can add more if you need to tie into something that's more unique, but there's several of them that are just default.
And those are global Android event names.
Correct.
Because this Android application convenience that comes from NativeScript is just it's a helpful aid.
Yes, very helpful.
Event. Okay.
Unless you want to memorize result activity dot whatever, you know.
Okay.
Yeah, it can get pretty messy in a hurry. So
okay, I'm following.
Okay, so after activities, another thing to know is interfaces. And that's not the UI that we're referring to here. We're talking of...
Is this like a TypeScript interface?
No, not a TypeScript interface either. An interface, as in a collection of abstract methods that a class can implement. So this is very common in an object-oriented program. So Java, again, being object-oriented has the concept of interfaces. And so those abstract methods, you'll see them everywhere on third-party libraries and SDKs that you're going to probably run into when you want to create your Android plugin.
So this concept of an interface is basically, this is from the Java language itself.
Yes, this is, well, not necessarily Java, but I don't believe.
In this specific case, it is Java. That's their design behind it is that it is actually coming there. But a lot of languages use interfaces so that you have a standard API that you code against for that thing. And so it can match up your code to the callback, basically. Because it's going to call into your code, and so it needs to you have to have those functions available for it to call.
Yes, and that's what I get into here in this code sample. If you look here, this is straight from Java. This is the example from that Facebook login activity that we were looking at. So it's going to set up this callback, and there are 3 different methods that get called here, and those are part of the interface that they expose. Are you following that part?
I kind of am. This decorator thing's confusing me because I'm an Angular developer and I'm used to these decorators being like functions that add particular enhanced features to a class or something like that. What the heck is that overlay?
That is a decorator. It's a Java decorator. I actually don't know a whole lot about this, Nathaniel.
It basically tells the Java when it compiles it that this particular function overrides the default function that's there. And interfaces, typically they're empty. You're basically saying, I need this function available. And so then you have to declare that, and you have to tell it you're overriding the base class, because this is actually a class that you get back from them, and then you're overriding their class methods, these 3, in this case, with your own code.
Now, this is just a Java question. If I was in this Java code and I needed to modify it for some reason to work with NativeScript, and I removed that override decorator, what would happen?
Probably crash.
It would crash, you think so?
Yes.
Okay. That's good to know.
The application would crash when you went back from Facebook to here and it tried to call here. It would probably crash because the method would no longer exist.
Okay.
Or it wouldn't compile.
That sounds important. It is important.
In Java.
And as you use that in your plugin for NativeScript, you need to know that you're going to implement those interfaces. And there's only some minor differences typically between the translation. You can see here we removed the decorator because we're no longer in Java. So basically, it's almost identical if you look at this right here. You see the on success, on cancel, and on error. And again, that's straight from the interface that we were looking at.
Can you back up to the interface?
Yeah, you need to see that again.
Yeah, let's do that again. Okay.
On success, all right. On cancel, on error. So there's your 3 methods.
And you were referencing some class there, com.facebook.facebook callback.
Yeah, that is important to know. So you're accessing that Facebook callback class via the namespace com.facebook. You could set this to a variable, some constant if you wanted to
reference this.
Yeah, you could reference it. You don't always have to call directly through the namespace to get there, but that is the class, and then there's the methods. And so here's the comparison from Java to a TypeScript system. You see the decorators are gone, the public declaration on those methods are also gone. But more or less, it's very...
It's interesting that there's an object that's passed to the constructor of a callback, and that object has keys and values on it. And that's just, is that NativeScript translating that to the native class?
Yes, that is the way NativeScript does their overrides so they can talk to Java.
Because I see in Java, it's actually constructing the class, but then the inside of it has these properties. So we're basically constructing the same class, but we're actually providing it these overridden methods in the constructor.
Yes,
that is NativeScript who takes those properties from the constructor and is actually extending.
Correct. It creates a binding between the native Java side and the JavaScript side and links up the names just the way it is. And that way you're programming the same way you would normally program a JavaScript thing and you want to pass in a Java function set or group of functions in your object class.
That's very interesting, and it also sounds critical to know. If you're going to work with Android, are all the classes that you might construct in this way an override? Does NativeScript by default take the constructor arguments and extend the class that way?
Yes.
That's pretty typical.
Yes.
Okay.
And so you're following the interface part.
I'm getting it all.
Activities and interfaces.
Ever wonder what we intelligent, independent, adventurous types drink? Celestial Seasonings herb tea. They call this one Lemon Zinger. Celestial Seasonings. Teas more tastefully done.
I can't believe it. Don't you ever quit? I've been away a long time, and my roommate's still going strong.
Renews it Roommate Air Freshener with twice the freshening liquid so it freshens air longer than Magic Mushroom.
Long-lasting roommate.
You're going to need to get that for you, Nathaniel. Let me see this now. So there's something that I want to go to a particular channel that I really love. This one I probably watch all the time.
Do we really have to?
I'm sorry, but this is the channel. You just made me watch Android. Actually Apple has a rich set of development tools. And they're important to note because all these development tools really work with NativeScript out of the box. And in fact, NativeScript wouldn't work at all without these developments. One in particular, Xcode. It is the de facto IDE for OS X development, iOS, Apple Watch. Basically, anything that you would develop as a software engineer for Apple might go through Xcode.
So you need it.
Definitely need Xcode. And in fact, you couldn't build for iOS without Xcode. Unless you're going to use the new nifty NativeScript Sidekick, which would let you build in the cloud, which is... but if you're going to build locally, you're going to have Xcode installed. And the development environment is based on a couple core concepts that are really important to understand. For one, back when Steve Jobs kind of brought around the development environment, it was based around Cocoa. And Cocoa is really kind of it encompasses the whole framework of Objective-C development. And Cocoa Touch in particular basically expands that Objective-C frameworks to provide mobile-specific functionality. Touch and mobile devices are very specific, multi-touch events, multi-touch controls, accelerometer. All this stuff is not things that you need on a desktop laptop. So it's important to understand that this Cocoa Touch library really is kind of at the fundamental base of a lot of things you work with for the iPhone. There's also this mention of Swift, and a lot of people say, what is this Swift thing? Objective-C is hard enough. What is Swift about? And just a phrase right from Apple, Swift is a general-purpose multi-paradigm compiled language. It's developed by Apple for iOS. You can use it for macOS or Watch. And it is designed to work with Cocoa and Cocoa Touch, which is Objective-C. So the interesting thing about Swift is that it is more JavaScript kind of based. It looks a little more like JavaScript, so it is definitely friendlier than Objective-C. So if we have Cocoa Touch that's at the base, and we have Swift that is now involved, we have this rich set of Objective-C libraries, and then we have Swift, which is really almost like a friendly face to Objective-C. Right? So we understand this Cocoa thing's involved.
We understand that it encompasses these bodies of languages, whether it be Objective-C or Swift. And this is kind of an example of a small difference between Objective-C and Swift. On the left, you can see it looks a little more like JavaScript. Objective-C is a little more terse. It's certainly approachable for some, but it's not as friendly. So Swift, to expand on that a bit more, the really neat thing that Apple did is they said, you know, we don't want to offer yet another programming language unless it all interoperates together. And so one of the nice things about Swift is it lets you interface between Swift and Objective-C code. You can use Swift classes in Objective-C and vice versa. There's a particular magic they use to do that, which I want to get into. But the mix and matching of these two languages is really important to know when you start wanting to develop more and more for iOS. So, you know, obviously as like web developers have this really rich set of like open source libraries on NPM. NPM registry has like a ton of libraries. And so Apple developers are also, it's just as thriving of a community. It's probably like slightly smaller just because the web community has become so large. But there is also a rich set of open source libraries from Apple developers. CocoaPods, actually it's not this. This is CocoaPods. And CocoaPods is actually really encourage sharing of open source libraries. They could be Objective-C based. They could be Swift based. Sometimes you'll have even watchOS specific libraries. A wonderful place just like NPM.
Yeah, so this is like NPM for iOS.
It's very much like NPM for iOS, and in fact, the way you interact with it is very similar. On the right, there is some really cool stuff about it in similar way that NPM makes things very convenient. The CocoaPod allows you to define the specs where they are, where the repo is, and then also dependencies. So just like in a package JSON file in NPM could actually define dependencies and dev dependencies, you can also have the same type of dependency set in a CocoaPod. So a CocoaPod may depend on some other framework altogether. This pod file could actually define that dependency, install this, pull everything down. The neat thing about the way that they design CocoaPods is that they're split up. So it actually installs two different projects, and one that manages the CocoaPods independently of your actual Xcode project. This is important to understand because when you start integrating with CocoaPods, there's actually two Xcode files that are generated. Generally, when you create an iOS project, there's one single Xcode project file, but the second you start integrating with CocoaPods, you'll have two. One is a workspace file, and the workspace file actually brings the two worlds together. It basically brings CocoaPods in with your project. And so often you always want to work with the workspace file when you're dealing with CocoaPods being integrated.
How important is that?
It's very, very important. If you actually had tried to run your project from the wrong Xcode file, it will crash and burn. And actually it won't be able to find anything. It wouldn't even be able to compile. So it is very important.
Okay.
So if just in numbers, just to kind of give you an idea, you know, we got a couple thousand libraries there on CocoaPods, 37,000 to be exact on recent numbers, you know, over 500,000 on NPM. So obviously the NPM community is quite large. The interesting thing is that some of those NPM numbers are actually from NativeScript itself, which pull in CocoaPods. So some of the numbers on NPM are actually CocoaPods. How could we use these CocoaPods with NativeScript? There definitely is a very, very simple way to do this.
You need a new TV.
You know, you thought the connection would be better in New York. All right, so there is a very simple project structure to these pods, and very similar to how you were shown on Android, where the source would be at the root. We're actually looking here at the source of a plugin as well. NativeScript prefers this very specific structure where you got a platforms folder inside the plugin folder, and then an iOS folder to designate these are very iOS specific files. The pod file is nothing to do with NativeScript. That is all Apple development. And to look at what the pod file includes, it's simply just a pod declaration. So this pod declaration is all you need. It's actually surprisingly simple, and you feel like you might be missing something, but that pod declaration right there would pull down the SwiftyCam CocoaPod. It would actually integrate the whole CocoaPod into your iOS project. When you run your app, you would have all that code now available to you.
And you say run your app, you mean the NativeScript?
The NativeScript app. So as far as including all these rich set of Objective-C and Swift libraries in your NativeScript project, this is how simple it is. Including the pod declaration. You can go find any CocoaPod out there you want, add this CocoaPod inside of this proper structure, and you put this pod file in there declared, and NativeScript will pull that in. Supposedly. Doesn't get it actually does not get added automatically.
So there's another step?
There is another step. So generally what you want to do when you do this, and there's a number of ways you could really integrate CocoaPods in, but the ideal way is to really set up an internal plugin folder. And this internal plugin folder would be inside the root of your own NativeScript app. This is one of the ways that I personally prefer to integrate with native APIs. It's the quickest way because you're working within your app and you can right away start actually developing with that code and develop it out, which you may later want to open source and publish as a plugin. That is something I do sometimes, and I think you guys do as well. So sometimes it's nice to share it out and let everyone kind of improve upon it. So this is a very basic structure, but because NativeScript works within this web scope of development, I think someone mentioned earlier today that one of the goals of NativeScript was try to bring kind of this web development frontier, kind of in the native space. And so we have this ability to integrate with these native APIs through NPM. So this NPM package JSON, all we're saying here is that we got the name of our plugin here. We're going to version it just because version is required by NPM to have in your package, and it's definitely a good thing. You're going to want to version your plugin. And then inside you have a NativeScript key. All this is saying is what platforms in NativeScript are supported by this plugin. So right now, if I was just integrating with a CocoaPod, I'm just going to support iOS. So I'm just going to indicate the minimal version of NativeScript.
Do you know if that works the same way for Android?
This is the same way you would do it for Android, actually. You might have the same package file, but you might add an Android key under platforms with the same minimal target.
Okay.
So the minimal target is just saying that this plugin specifically is going to work from 3.0 and beyond. There's obviously NativeScript 2.5, which a lot of apps still use, and you could target 2.5, that's fine. They change a little bit of their lifecycle hooks with NativeScript 3.0, so it's usually a breaking change between NativeScript 2.5 and 3.0, especially when we're talking about Vue plugins.
Okay.
Okay. So we've got this package file here. It's sitting within the structure of our internal plugin here. We're doing this mainly so we can add this plugin into our NativeScript project. So what we can do at this point is we can say TNS plugin add NativeScript my plugin. What TNS is going to do is it's going to default to look locally first. So it's going to find NativeScript my plugin is a folder right inside the root, and it's going to see that, and it's also going to pick up the package JSON because TNS works with NPM. And so it's going to say, I see a package here, and it's going to add that plugin into the NativeScript apps dependencies. What that's going to allow us to do at this point is it's going to automatically pick up the pod file, and when we build iOS in NativeScript here, it's actually going to build that CocoaPod into our iOS app. So this is kind of a view of what happens after doing TNS plugin add. We've got a local file include for this local plugin. That is just going to reference it locally. You could reference any other local plugins, of course, in the same way. Excellent! And that's it. We actually are ready to code against this Objective-C and Swift code right now. That's all it took. What's very important to understand is that NativeScript works with Objective-C directly. It does not work with Swift directly. It actually works through Objective-C only by the Swift bridging header, which makes the Swift code available to Objective-C. And since NativeScript can work with Objective-C, that's how we as NativeScript developers can actually work with Swift. There's been some talks to actually create a runtime that's specific to Swift. So one thing I want to mention is that when you start integrating with a CocoaPod, one thing that's really nice to do is create and isolate that plugin integration. This is really important because there's a lot of native code you could start typing in here. You could start typing all sorts of stuff against CocoaTouch, against this CocoaPod you included, and you want to be careful about how you intermix that into your app code, because who knows, down the line you may want to pull that pod out. Maybe it's terrible. Maybe you've gotten 2 months down the line and this pod doesn't actually do what you want, or worse, has a crash and actually ends up crashing your app, and you gotta find something else that's going to work better. For this reason, it's a really good practice to isolate all the plugin code inside. I'm going to use TypeScript as an example here, but inside this plugin folder here, I've got my plugin iOS TS. This is a TypeScript file. I'm just exporting a class. It's got the suffix on there. NativeScript is going to pick up that suffix and actually exclude the suffix, build it into just myplugin.js when it runs a NativeScript app. So it's just included like a standard JavaScript file. But let's say we got this class sitting here, and what we really want to do is in the package, we got to make sure that NativeScript knows now that we want to isolate this native API code into this very specific file. And the only way to do that is to tell the package JSON that the name of this JavaScript file specifically is going to be called myPlugin. MyPlugin, notice we don't use the suffix there.
Why?
The suffix is excluded automatically by NativeScript. When we build TNS run iOS or TNS build iOS or TNS run Android, that is what's going to tell NativeScript to say, oh, I'm building for iOS, I'm going to take all the suffixes out, and the JavaScript it ends up with for the Android build or the iOS build don't have any of those suffixes there.
Ah.
That's important to know as a plugin developer because you want to develop platform-specific plugin code. So this very specifically is for iOS. I'm telling the main that it's just my plugin, and very curiously, I'm leaving the .js off.
Why is that?
You want to leave the .js off to allow other developers and people who might use this plugin to webpack it. If you have the JS on there, you're going to cause all sorts of problems for Webpack. So we have a couple options as a TypeScript developer. We might want to allow someone to actually integrate with this plugin and get rich, strong typing on our plugin. We could create a rich service library with very specific methods, signatures. We want all of that stuff to be strong type, so when the developer uses it, they actually get errors at compile time. It's very nice. So one really nice practice to do is to add a typings key in the package, specify the name of this typings file. I'm just going to use index.d.ts, and I'm going to update that manually. This is an example of what the index.d.ts for this class would look like. And this is just declaring that there is a class named myPlugin. In doing so, basically will allow me to import that symbol. If I do import myPlugin from this library, this plugin, I would actually get strong type checking against everything that's defined in there. Now, of course, you can also have TSC actually generate the typings for you so you don't have to manage it manually. But it is nice to have an index file that you can condense Android-specific and iOS-specific typings down to one file. Because when you TSC compile .iOS or .android, it's obviously going to generate typings for .d, .iOS, and .android. So you'd have two different typings filed there. And you really want to bring a common denominator down to a single typings file, because as a plugin developer, you really want to make sure your API is the same across both. That's the beauty of NativeScript, is you can provide the exact same API on two totally different platforms running two totally different languages.
That makes sense.
So there is a thing that this CocoaPod in particular, it would be amazing, right, if we could generate TypeScript definitions for this native code.
Yeah.
I mean, it'd be pretty mind-blowing.
It would be very cool.
So one development workflow, if we were going to go with this internal plugin structure inside of our project, like one way would be to make changes to the plugin code. Then we could compile that plugin Using TSC, we could pass the -D flag. That's going to give us our TypeScript definitions off that iOS file. And we're just specifying to compile that one file. We're doing this is very manual. This is one way you could do it, and it works just fine. This is going to generate the TypeScript definition. I would usually take those definitions and then copy and paste them down into the index file, because I like to manage this index file. It's just it's a nice way to do it. Then to have NativeScript pick that up now, because we've made changes to the plugin, you can do a remove, which is going to remove it from the native Xcode project, and then we're going to add it back. This is one safeguard you can do, because sometimes in native development, when you make changes to the CocoaPod, or you make changes to native files, the Xcode can be funny sometimes. So it's a good practice sometimes to remove the plugin, add it back. It takes 2 seconds, you're safe. When you run it, you know for sure that's going to have your changes. Lastly, we run iOS. That's going to pick up any plugin changes we made and actually include the native plugin. So if we look at the steps to these CocoaPod TypeScript definitions, because we don't want to work willy-nilly and just think that we're typing against the right thing or right method call, not to mention that methods have an interesting way of compounding each other when you look at Objective-C method and how it translates to NativeScript. So first off, we want to install the TNS platform declarations. These are awesome. This is going to give you rich IntelliSense off iOS and Android, all the native APIs. And then in addition, what we want to do is add this references d.ts file in the root. So out of the box, when you create a NativeScript project, you don't have this references D file. This could change in the future, but right now there's no references file to start. So you want to add this after you add these platform declarations. And then you want to include these two references. They're basically going to reference all the definitions for all the APIs on iOS and all the definitions from Android if you're doing Android development. And then we can run this command. This is a global. You could set this in your bash profile if you want, if it was going to be the same folder you always want to generate these typings in. But this is going to actually build the app, but this time it's going to queue the NativeScript CLI to generate metadata for all of the Objective-C third-party code that you have in addition to all the native code in your app. So this is an example output after building the app. We can actually see that the CocoaPod SwiftyCam that we've included is installing. This is a really, really good sign. This will let you know for sure, okay, I've got the CocoaPod included right. It looks like the version number's right. You might even see version number differences there depending. That's a good thing to kind of keep a note of, because sometimes the versions can be vastly different, of course, between one CocoaPod and the other. So what that's going to do is it's going to generate this typings folder. This typings folder is going to have 2 folders in it, one for the simulator, which is i386, and then you've got ARM architecture, that's 8664. That's generally for a device. The difference between them does not matter. I would pay no attention to it, because generally all you need is everything that's inside of one or the other. We're just going to look inside i386. We can see all these Objective-C bang, and then it has the name of the class. These classes are all straight from CocoaTouch, which we were just talking about. In CocoaTouch to CocoaPod to this, what we see here. It's important to know that's what we're looking at. Furthermore, what's really cool when you do this is that it actually generates the TypeScript definition file for the third-party pod that you included. So this is actually the TypeScript definition for SwiftyCam, and NativeScript created this for us. This is actually a full, completely valid TypeScript definition for this native class that we just included. This is a Swift library, for instance, and this has all the invocations that we need to know about.
So as a developer, if I add these definitions for that pod, it's going to provide me with some good IntelliSense as I'm developing, correct?
That is correct. It's going to give you, not only that, but it's going to let you know what's even available, because some things might not be available.
You mean you don't have to guess what the name is?
You don't even have to guess what the name is.
Wow.
It actually is kind of mind-blowing. Objective-C has very interesting method signatures, and they can be very unwieldy sometimes, and even difficult to understand how to translate that. So doing this TypeScript definition actually alleviates all of that, because you don't need to know how to translate it. It actually is completely type checked for you. So the workflow I was just showing with the internal plugin and actually compiling that is quite a burdensome workflow. We're talking about compiling with TSC manually a plugin that's inside your project just to get a JavaScript file out of it, then removing the plugin and adding it back to actually get that plugin in your project. That's
seems like a lot of work.
It's a lot of work. So, you know, if we're looking for a faster workflow, one I really like to use is actually take the plugin code, put the file right inside your project. Keep it inside a folder, because again, it's still important to scope your plugin integration in its own JavaScript file. This is just going to help you in management in the future. It's also going to help you stay focused when you're dealing with this native code. So we're going to take that iOS file that we had inside of that My Plugin folder. We're just going to drop it right inside of our app folder. This is going to give us the ability to work with it directly inside of our project, alleviating the entire workflow that I just mentioned.
Wow, that's pretty cool.
It's a nice way to do it. And this is the definition file. So again, when we were looking at the plugin, we had an index.d.ts. But that's kind of irrelevant, because the index.d.ts was purely for the folder in the package JSON, which is meant to publish. So if we're going to have a package JSON and we're going to have typings, those typings only need to specify index.d, because number one, it's a good practice, but also number two, it's going to include those typings for that plugin when someone installs it. So if you're going to share your plugin, the typings is important. But here, we just want to develop fast. We want to be able to work with this plugin right away. We don't want this burdensome workflow. We're not going to publish it to the world just yet. We need a couple months working with this thing and really get it figured out.
So by moving it into the app folder, what does that do in regards to the path?
So what we can do, the thing is that you got to keep in mind here is because iOS is on the end of it, you can't import from .ios. You wouldn't want to do that because NativeScript is going to remove the iOS extension. So by the time it builds down to JavaScript, your import path is going to be wrong. So you need a definition file internally that just declares the name of the class. Now you don't even need methods or properties inside of this definition. That's kind of irrelevant here unless you want type checking for yourself, then it's totally fine. You can put those here. But mainly what we want to do here is just allow us to interoperate with this plugin inside of our app and get around the TypeScript hurdle that we deal with this iOS extension on the end. So this declaration file is saying that we got this My Plugin class. That allows us to now import it inside of our project as we would any other class. So we can see we're importing from the My Plugin folder and specifically the My Plugin file. This is a TypeScript file I'm importing that from, and we can see it's coming from just My Plugin. Why? Because that's the definition file that's actually getting picked up by TypeScript. When NativeScript runs that though, and it actually enters the runtime, that is going to load the actual JavaScript compiled file. And the TypeScript definition is meaningless in the runtime environment. We want to talk about these CocoaPod definitions, but specifically we want to talk about how we can get the strong type checking against that CocoaPod. So if we take a look here, this is that Objective-C class that we had generated for us by NativeScript, and we want to get the strong type checking right within our project. We want to be able to construct the SwiftToCam button. We want to see all the methods available to us. What we're going to do is we're going to remove all of the other folders that NativeScript generated for us in the typings file. So if you remember, there was an i386 and there was the x86-64 folder. Those are meaningless. We don't need them anymore. The only reason we generated this was to get a TypeScript definition just for this CocoaPod. And it's worth noting that when you start integrating that back, and you bring that plugin directly into your project, you do want to fix your package JSON back to normal because you no longer are using that workflow anymore. You instead are including the plugin directly in your project. You don't need a main here because the JavaScript file doesn't exist inside this folder anymore. We're just keeping the bare bones package setup just so we can include this by name into our NativeScript project, just to bring the CocoaPod in. That's it. We're not going to use any JavaScript inside of this plugin. This is what you'd call a CocoaPod only plugin with literally no implementation. So back to this declaration file. We've got it included. We've got the references file here. We've got iOS and Android. We're going to include one more declaration at the bottom there, and that's to this Objective-C SwiftyCam declaration file. I've got it sitting right there inside of the typings folder, and that alone is actually going to allow rich IntelliSense when working with that native library right inside of our project. So here I am right inside the Hello World demo. This is right from a bare bones setup for NativeScript, and I'm already getting IntelliSense on Objective-C code right here inside of this demo code.
Sweet.
It is pretty amazing. So there might be a couple problems with this though, because as I mentioned, it was built with Swift.
Oh my God, look at that face. You look like my next mistake.
Well, yeah, I mean, it is a mistake because when you start working with Swift, there's a lot of problems that can happen, and you are going to run into some stumbles. And the main problem is that Swift is an advanced programming language. Objective-C is kind of basic in terms of modern-day programming languages. Swift introduces these advanced enum structures, and this is probably the most critical component that you run into in NativeScript development, because any Swift library that uses an advanced enum structure is going to be completely ignored by NativeScript.
By advanced, you mean just a typical enums?
So that's a good question. So this enum we're looking at right here, if you know, an enum is just, it's basically enumerated from 0, 1 for every single case that you have inside the enum structure. But what Swift allows you to do is not only have from 0 to whatever enumerated options, you can also have properties and even methods inside the enum, as if you really needed that. So in order to work with them, we do need to do a couple things. So we've entered the territory of, we do need to make a couple modifications to the native code. And we need to do this because we want to interact with this library with NativeScript, but we want to open up this Swift library entirely to Objective-C.
If this had been written with Objective-C, you wouldn't have to do this.
That's correct. This is just a Swift issue.
Okay.
So we're going to look at this TypeScript definition file, and what you'll notice in particular is that with everything collapsed, we only have 4 declarations here. These enums are not mentioned in that definition file. We've got a camera selection enum and we've got video quality, but if we look at the definition, those aren't there.
So in basic terms, NativeScript doesn't know they exist?
NativeScript doesn't know they exist.
Oh.
So this is a problem that we have to deal with. And you can see if I search camera selection, that enum is definitely not there. And what is also important to note is that for any enum that is omitted when compile time happens and NativeScript doesn't know about it, it also will not know about any other method that uses that enum, whether that enum be in the method signature or used within the implementation of the code.
So you mean you could be missing properties and functions?
All sorts of stuff. So there is a nifty thing that they introduced actually back in Xcode 6.3. So this was actually a couple of years ago. This has been available. What you can do is you can use this @Objective-C attribute. This is kind of like the decorator in Java, where we had an override. It's somewhat similar. What it's doing is it's flagging the compiler to actually say, you know what, we want to expose these properties to Objective-C. And so this @Objective-C declarator is going to allow us to do that. Also in bold, one of the most important answers you could get on this topic. You must declare an integer raw type. This is critical, especially with these enums. You can see @Objective-C enums must declare an integer raw type. It could not be more clear. So in order to do that, what we'd have to do, we want to work with these enums. We want to interact with this code.
we want to convert this to look something like this. And the difference is just that Objective-C modifier that we add in front of the property, and we can see we add a :int. Just as that Stack Overflow answer mentions, it must extend the int raw type. Those two things right there is what's going to open up this entire Swift library to NativeScript. It is one of the most important things to know when interacting with Swift, and it might be the only strange thing that you encounter with Swift in integrating with NativeScript. In fact, to date, for myself, it is the only thing that I've encountered where I need to modify Swift code.
So other than this, you've never had to really touch the Swift for a CocoaPod?
That's correct. So as we can see, add Objective-C modifier there, we've got :int that's extending that. Let's look a little bit behind the scenes of why this is important. And you can kind of understand what's going on. If we look inside of the project, in Platforms iOS, in the build for the emulator, we're going to follow this path down to what it built for our iOS simulator. We're going to see inside we have this SwiftyCam framework that NativeScript didn't do it. This actually is built by Xcode, because NativeScript, when it builds iOS, it actually uses Xcode build, which is a command line tool installed by Xcode, and it runs Xcode by the command line to build our project. NativeScript is not doing any magic here. This is just iOS development. The SwiftyCam framework is created by Xcode build. That is our CocoaPod, and you can see it generates these header files. These header files tell the runtime what is available to call, what the signatures are, and what exactly we have access to. In particular, you will find on any Swift library you integrate a -swift.h file inside of this folder on the framework. This is what's called the Swift bridging header. It is very important. It can also be used to determine what is available. Whatever is not in this file, NativeScript does not know about when you're integrating with a Swift library. This is a critical thing to know and understand. This right here is a look at what one of these header files looks like. It is not something you want to read casually. It is very terse, but it basically defines every single property that might have been coded inside of the Swift library and tells Objective-C, hey, you can work with me through this. I'm giving you the map to my code. This is the map to the Swift code. So what we want to do is we modified those ints, and now what we want to do is we fork that library. That's an open source CocoaPod, and what we want to do is we want to change our pod file to designate this custom fork. This custom fork now is going to actually be the version of the pod with our add Objective-C modifiers and the int raw type extension on these nums. This is how we can get past this Swift barrier with Objective-C.
When you do that, you're actually bypassing the CocoaPods repository that houses that pod itself.
That's correct. And what we want to do when we make a change to the pod file, it is important, like I mentioned earlier, you've got to remove the plugin and add it back. You're making changes to the CocoaPod. Those things are deep down in the build project that NativeScript already made for the Xcode project for iOS. You got to remove that and add it back to make sure that that CocoaPod change that was just made to use our repo is actually included. And now what we can do at this point is we can regenerate our TypeScript definitions. So we can say now, okay, well, I made those changes. I want all the typings now. And I mean all the typings this time. This time when we run our project, we'll see, and again, this is another good sign. You want to make sure we make changes to the pod. It's going to pre-download SwiftyCam from this custom repo that we forked and made the changes to. We can see that right here in our runtime. So we've got these changes done. We're going to regenerate these typings. We've got our declarations path. This is just a global variable that we're setting in the shell that NativeScript is going to pick up when it builds our project. But it's going to queue up the metadata generator when it makes the build, and it's actually going to generate all these TypeScript definitions for this pod. We can see it's got our repo right there. This is definitely should be the right one with the changes. And sure enough, when we look at that definition file, we now have
a lot more properties. Actually, there's a ton more stuff that opened up. We just opened up that camera selection enum that I was just talking about. Curiously, you might note that by default, when these are created, it actually uppercases the enums. That's a critical thing, but again, you've got the definition file there, so you're going to get strong type checking against this. So you wouldn't accidentally do a lowercase r because your TypeScript compiler would actually stop you. But that's an important thing to note. This is the look at now the Swift header again. So this is after we have made our changes. We've rebuilt the project in the compile time, not NativeScript. This is just iOS and Mac development. Regenerates the Swift header file, and now we have these Swift enums opened up. You can see the type def. This is what is saying, hey, Objective-C, I am now defined, and you can work with me.
First, the bad news. 3 out of 4 unsuspecting people will get gingivitis, an early form of gum disease. Now, the good news. Listerine Antiseptic is the only non-prescription mouthwash accepted by the American Dental Association for its significant help in preventing and reducing plaque and gingivitis. And Listerine still kills bad breath germs. So brush, floss, and use Listerine. It's good news for you, bad news for gingivitis.
Our plugin layout, the original layout was we had a demo folder, we had our source code, our ignore files, documentation all in one directory. This worked fairly well initially. It allowed us easy access to link our plugins to a Git repo, easy editing a demo, reinstall source code for testing demos. There's a lot less directory navigation, and everything was in the root for the readmes for GitHub. So why are we abandoning it? Well, that would be because of the new versions of NPM. In the original layout, you had all your source code and then you had a demo folder. So that way you could do tns plugin add ... or npm I ... --save. Both of these would do this to your node modules folder. Do you see that little picture that says NativeScript -ns -wikitude? You see that little icon there. What is that? It is a symlink or a junction that points back to ... Why is this so bad? Anybody know what that folder is? Yep, it is your demo folder. Putting a folder with another copy of the runtime and or core modules in your app's node modules is bad enough, but it is recursive. So in your demo folder, when you have a symlink that links you back to your root folder, that root folder then goes back up to your demo folder, which then links back to your root folder. So it recurses back around and around and around and around in circles. When you have multiple copies of your node modules and multiple copies of your TNS core modules and multiple copies of your platforms, the application will just crash when it starts up because it'll just get totally confused if it even compiles. So what is the better way? The better way is to create a demo folder and then have a source folder next to that div folder. And then in your root directory, you also add your git ignore and your license file. Because the source folder is now a subfolder of your root folder, just like the demo is a subfolder of your thing, when you do an npm I or a TNS plugin add, you're linking to the source folder. And so even though it creates a symlink to it, it is not recursive because the source folder does not link back to the demo folder. It seems like such a pain to have to change, but this new npm linking system has some unexpected good side effects. In the old system, each time you made a change to your plugin, you'd have to deinstall it and reinstall it, deinstall it, reinstall it. And so you could end up with a lot of time wasted deinstalling and reinstalling a plugin. One of the early shortcuts that I devised was to copy your plugin source code into your demo folder and then link to your copy inside your demo folder so that way you could make the changes locally. But the downside of that would be that you had 2 copies of your source code. You had 1 copy inside your demo folder and then you had 1 copy inside your root folder. You would have to manually copy it back and forth to make sure that your plugin in your root folder was updated, so when you did your npm publish, you could have that automatically published. And so the biggest issue I found with that is which copy was the latest. If you walked away and you came back later, you're like, okay, which one of these copies is later? With the new npm linking system, you keep 1 copy of your source code, period, in your source folder. Because it links from your node modules to your source folder, anytime you make changes to your source, the node modules has that change automatically. With the -- sync all files, because that automatically syncs all the files in the node modules, your application on your phone or an emulator gets the latest files. And so this simplifies things. Searchcode.nativescript.rocks. What is Searchcode? I've never heard of it. Searchcode is a new site that has been in beta testing for the last couple of months to allow developers to easily find snippets of code from all the plugins in the NativeScript ecosystem. How in the world does that help me write a plugin or an application? Do you know off the top of your head how to write something that works with the call web view should start load with request navigation type? I'll tell you what, I don't even know what that one is off the top of my head. So the first thing you do is you go to http://searchcode.nativescript.rocks and you type in the search box, web view should start load with request navigation type. Look, there's 7 samples so far in the plugins on how people have used it in their plugins. By reading the source code, you can see and understand how you can use it in your plugin. That could just be just a little helpful for when you're developing your own plugin. Third-party integration. On Apple, it's CocoaPods. How to use CocoaPods? Well, in your plugin, you create a platform's iOS folder. In that folder, you create a file named pod file. What do I put in the pod file? Well, inside the pod file, you can put several different things, but the main thing you do is pod, and then inside quotes, the name of the pod, and then a comma, and then the version if you're wanting to lock it to a specific version. The name and version is whatever you see on CocoaPods.org. In addition, you can choose where the source for the pod files come from, or even point it to a Git repo. The other option on iOS is frameworks. What is a framework? A framework is another way to distribute a library on iOS. In addition to the built-in libraries on iOS, which most of them are frameworks, there are some other example frameworks like Spotify, Estimote, Star Printer. The frameworks are all pre-packaged compiled code. Just like a CocoaPod, you put a framework inside your platform's iOS folder. However, there's a couple other things you may have to do. The first thing you want to check is you open up the actual framework folder and check to verify it has a module.module map file. If it doesn't, you're going to have to create the module map. Creating a module map is pretty simple. First of all, you give it a name, module.module map. The next thing you need to do is figure out what the main header file in the framework is. And then you add any linking and you add your export. That doesn't sound that simple. Well, if you look at this, it's very simple. Framework module Spotify, umbrella header Spotify.h, export star, module star, export star. There's also some additional advanced stuff you can do in it, like if you need a link in some third-party stuff like SQLite. And the last tip I want to give you is that sometimes you need to build a build.xc config file to help Xcode find the libraries or header files listed in the module map or in the framework. The xc config file is a configuration file for Xcode. It allows you to set different parameters for like where directories are at, the linker flags, your compiler flags. This file is also put in your platform's iOS folder. Android third-party integration. On Android, the default build system uses Gradle. Gradle also allows you to add any number of different libraries. Typically, they end with a .jar or a .aar. You can find standard Gradle plugins from a couple different sites. One of them is android-arsenal.com. Another one is bintray.com/bintray/jcenter. And another one is search.maven.org. All three of these sites are standard sites that list a ton of different .aar or .jar files that are different plugins that you can include in your build of your application. The first step to use one of these as a plugin is you create a platforms/Android folder and you create a new file in it called include.gradle. Inside the include.gradle is just a set of commands that list out how Gradle is supposed to find your plugin and what it's supposed to do with it. Typically you have an Android, then product flavors, then the name of your plugin, and then dimension, the name of your plugin. This basically sets up this particular plugin to be named and configured under the name of the plugin you want to use it as. The next part of the include.gradle file is the dependency section. In that dependency section, you add any of your compiles. The compiles basically point to the plugin name and what version you want to use. So in this example, we're using com.tom_roush:/pdf-android:1.8.9.1. When Gradle sees this file, it will automatically download that file from the standard Android repo and include it in your build process. In addition to the Android section and the dependencies sections, there's also an All Projects section. One of the keywords in the All Projects sections is repositories, and you can list out where it is supposed to actually download the files. By default, it is going to pull it from Maven, but you can also add JCenter, Maven Center, or even local directories. iOS metadata generation. iOS has two different metadata generation systems. The first is a very detailed metadata system that generates this huge set of XML files that have all sorts of detailed metadata about all the third-party libraries that are being linked into the application. To build the detailed metadata, you basically need to set environmental variable TNS_debug_metadata_path to a location where you want the metadata generated, and then do a TNS build iOS. When the TNS build iOS detects that environmental variable built, it'll automatically generate all these XML files in that directory you pointed it to. To generate the TypeScript typings, it is the exact same thing. You set an environmental variable called TNS_TypeScript_declarations_path, set it to what directory you want the typings to be in, and then do a TNS build iOS. When it detects that environmental variable, it'll automatically create all the different typings for all the different libraries that are being included in your application. The typings is normally pretty complete. However, sometimes you want to see the detailed data, which gives you a little bit more information about, like, is this part of the framework? What other parameters can this take? Generating the metadata is very helpful in being able to determine if the functions are being seen properly by NativeScript, so you don't waste a lot of time trying to call things the documentation says should work, but for some reason the metadata is not generated for. In addition, generating the typings right away allows you to quickly create your plugin because you have all the IntelliSense help for all the functions that are available in the plugin. Android metadata generation. Android has a single metadata generation system. It can create TypeScript typings. Now, the TypeScript typings that Android generates are not quite as good as the iOS side, but they're very useful. There are two ways to build typings on Android. The easiest way is TNS build Android --Android typings. This will generate you all the typings for your application. The second way is you have to download a project called Android-DTS-generator. Then you have to build the project, and then when you run the project, you can pass in which jar or AAR files you are going to want to create typings for. The second method is a lot more complex to do, but it allows you to generate typings for just a single jar file or single AAR file. Currently, the best version of the Android DTS generator is a fork in Richard Smith's repo, which has several bug fixes that have not been accepted in the mainline. Just like the iOS side, generating these typings will give you IntelliSense while you're trying to build your plugin. Finally, I have a couple plugin tips. The first thing is should you make a dependency from your plugin to TNS core modules? By dependency, I mean add it to your package.json file in your plugin. This is a big no. If you add a dependency in your package.json file to TNS core modules, then when npm installs your plugin and it sees that you have a dependency on this, it, in a lot of cases, will install TNS core modules a second time as a subdirectory of your plugin. When your application is built, all of a sudden now you have two copies of TNS core modules, and the core modules will cause all sorts of weird conflicts if your application even runs. If you want to lock your plugin to a specific version of TNS core modules, what you want to do is use the peer dependencies key. With that key, you can actually say that this plugin needs a peer of TNS core modules of a specific version or a specific set of versions. Is TNS forgetting to tell you something? Why do I say it that way? Because unfortunately, TNS has a bad habit of not reporting all of your logging. This issue mainly occurs on iOS, but can occur on Android also. If you find you're missing logging, or if you're finding that your application seems to be crashing but you're not getting the logging out, then there's a couple ways to get this logging out. On Android, it is very simple. You just need to type adb space logcat. That'll give you the entire log from the point where the device started. If you want to clear this log, you can type adb logcat -clear and it'll completely clear the log. Then when you do an adb logcat, it'll show you everything from the point the log was cleared. On iOS, it is a bit more complex. You need to open up Xcode, go to the Window menu, go to Devices. At the very bottom of the screen, towards the very right side, you should see like a little arrow button that you need to click. This will pop up the logs on your device. The Xcode method is very useful because Xcode is already on your machine. However, there's a much more simpler way. If you use brew to install lib iMobile device, it has a handy command called iDeviceSyslog. iDeviceSyslog will show your log in real time from your device. One final note, when using adb logcat or iDeviceSyslog, I would recommend you use grep to filter it down. You can filter it by either the process ID, by console, by the name of the application. Any one of those things will allow you to filter the number of messages down. Now sometimes you might want all the messages the device gives you because there's other messages, warnings, hints about what else is going on the device that might be directly related to your application. In that case, you just would not use a filter at all. In some of the newer versions of the TNS command, there is actually a TNS log command which works very similar to adb logcat or iDeviceSyslog. However, TNS log has been broken in a couple different versions of TNS, which is why I'm giving you the command so you can bypass TNS and get your full logging if need be. Plugin listings. How do you get your plugin listed on the plugin sites? I'm glad you asked. To get your plugin listed, you basically need to open up the package.json file and add a couple keys. The primary one that is the most important is platforms, and you tell it which platforms your plugin supports. Android or iOS or both of them, and you put what version number that your plugin actually supports. Most of the time this is going to be 3.0 or later. The next thing is an optional key called plugin. The plugin key allows you to choose whether your plugin supports NativeScript Angular, plain NativeScript, Vue.js, whether it's a Webpack plugin, which category you want it classified in, and other additional metadata. In addition to those keys, you want to add a keywords key and have the word NativeScript somewhere in it. As long as the plugin name has NativeScript or the keywords has the word NativeScript in it, the plugin sites will pick it up and automatically categorize it. In addition to the package.json file that is required, you should also have a .npm ignore which ignores your demo folders and your TypeScript files or any other files that are not needed to make the plugin run. This npm ignore file should be in your source folder. You can also have a .getignore file in the root folder, which allows you to ignore any files that should not be committed to your Git repository. If you've done everything correctly, then it should show up on plugins.nativescript.rocks almost immediately after you do an npm publish.
Thanks. Hey, I was thinking, I might watch a movie.
I am not programmed for friendship.
Now suit yourself.
All right.